Hello everyone, I'm Won Lee. Today I'm going to explain about expectation, what expectation means, how to get it. Okay, we already studied the random variable x and its probability distribution function f of x. So now we are ready to go. All right, let's see. Expectation. Expectation, in other words, expected value, mean and variance. We are going to see about the mean and variance in a population. Theoretical mean and variance today. Expected value of this spin wheel, like this roulette wheel, okay? Then we want to know how much can we expect to win, how much from this spin wheel. In other words, on average, how much do we win? Okay, same wording. Okay, here, 1,000, 2,000. Here, what? 6,000. And, I'm sorry, 1,000, 2,000, 3,000. Here, 6,000. Okay, for this spin wheel, let the random variable x be defined as x equal to amount that can be won. Then x will take only four values: 1,000, 2,000, 3,000, 6,000. So x is what? Discrete random variable, because it takes only four countable numbers: 1,000, 2,000, 3,000, 6,000. And the probabilities for each value are, probability of 1,000 is half. This is half. And the probability of 2,000, 1/4. This is what? 90 degrees. Probability of 3,000 is, this is 60 degrees, so 1/6. Probability of 6,000 is 30 degrees, so 30 over 360, so it is 1/12. Therefore, the expected value, in other words, mean of this spin wheel is what? 1,000 times its probability, 2,000 times its probability, plus 3,000 its probability, 6,000 times its probability, 1/12. The total is 2,000. So in other words, the expected value, expectation of this random variable x gonna be 2,000. We denote it by capital E of x. X, of course, capital letter, because it is a random variable. The expected value of a random variable x, which is 2,000, means that on average, you can expect to win 2,000, so that x of x implies the mean of x. You get it? Understand it? Okay, mean, average. When the random variable x is discrete, in general case, x can take values from x1, x2, xp. Random variable x may take p different small x's. Okay, and the probabilities for each value are f of x1, f of x2, f of xp, respectively. Then the expected value, in other words, expectation of the random variable x, is defined as ex, x1 times its probability, plus x2 times its probability, plus dot dot dot, plus xp times its probability. Shortly, summation xi times f of xi, okay, I from 1 to p. We shortly, briefly denote it by mu, Greek letter, pronounced as mu. Okay, that is average or mean of random variable x. You understand this simple spin wheel, then you can get the like a definition of a mean or average. Okay, variance. Earlier we defined, no, earlier means what? The data, we collect samples, then we can calculate variance, and we defined variance as the what? Average of the squared deviation. Remember that? For sample x1, x2, xn, the deviations are xi minus x bar. We call it deviation. That means they are x's here, then what? Mean is here, around here, x bar, then x1 minus x bar, x2 minus x bar, x3 minus x bar, dot, 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 xn minus x bar. There are n deviations. What should the deviation? This is for sample, okay? We defined deviation. What should the deviation of a random variable x be? It should be x minus its mean, mu, here, population. Then, how to calculate the variance of a random variable x? Then variance means what? Average of a squared deviation of x. So squared deviation average. Variance may be, can be, should be defined like this. You understand that? Then for discrete case, random variable x will take x1 to x up to xp. So xi minus mu square times its probability. What? Xi probability. F of xi. Sum. Because it is a what? Discrete case. Then we denoted sigma square. Sigma is also a Greek letter. And sigma means what? Square root of variance is a standard deviation, pronounced as sigma. You understand that? Compared with the case for samples. Samples means observed values from here. So I think it is not a big deal. You may understand that. Operations of expectation. Expectation operation. Mean is mu ex is xi times f of xi. This is like a definition. And x plus k, expectation value of x plus k is expectation value of x plus k. There is some steps. There are some 2 steps here. You may understand easily, even though you hate mathematics. Second, expectation of ax plus b is what? A times expectation x plus b. There are 3 steps here. It is an easy, say, formula, easy steps to understand that. Sigma square, variance of x, is a definition like this, right? And the variance of x plus k means k is constant value. So 2 steps, then you get sigma square. Some constant value added to all the value of x. Then the dispersion degree, variance, does not change, just plus some constant value. So this one is just the variance of x. Variance of ax plus b, 2 steps here, 3 steps, a squared times sigma squared. If you multiply a to x plus b is nothing, that it does not change the variance degree of dispersion, but all the value of x will be multiplied by constant a, then what? The dispersion degree will be a squared times sigma. Then what is the standard deviation? Square root of x. Square deviation will be a times sigma, right? Square root. It is reasonable, right? Okay. It is, I think it is in mathematics, but if you don't like this kind of a formula, then forget it. You can remember the result of these 4 things. Okay. Okay. That's it today. Thank you. Bye.